In Precalculus Lesson 15, we next solve rational inequalities algebraically. This lesson is from section 3.4 in the college algebra textbook. To begin with, let's solve the rational inequality x minus 2 over x squared minus 16 is greater than 0. Noting that there is a 0 to the right of the inequality sign, I'm going to grab this rational expression to the left of the inequality sign, give it the name f of x, so I now have the function f of x equals x minus 2 over x squared minus 16, which I will fully factor to get f of x equals x minus 2 over x minus 4 times x plus 4. Now, setting each factor in the numerator and denominator equal to 0, we have x minus 2 equals 0, x minus 4 equals 0, x plus 4 equals 0, and solving further to get x equals 2, x equals 4, x equals negative 4. These three x values go on a number line, from which we will create a sign chart. Note that both negative 4 and 4 come from the denominator, which means that the function is undefined at those two values. So I'm going to write the word undefined above each on the number line. And then x equals 2 comes from the numerator, so would be a 0 of the function. So let's write the word 0 here. And then we'll need to test an x coordinate or an x value in each of these four regions. Let's start by testing to the left of x equals negative 4. Let's choose, just negative 5 maybe. Between negative 4 and 2, we can choose 0. Between 2 and 4, 3. And then to the right of 4, let's choose, maybe 7. Now, testing these four x values, let's plug them into our function up here, f of x. And we're just testing to see if they would result in positive or negative function values. So negative 5 minus 2 would be negative. Negative 5 minus 4, negative, negative 5 plus 4, negative. A negative number divided by a negative times a negative would be a negative number divided by a positive number or a negative number. So my function values are going to be negative to the left of x equals negative 4. Let's try between negative 4 and 2, plugging in 0 for x. 0 minus 2 is negative. 0 minus 4 is negative, 0 plus 4 is positive, a negative number divided by a negative number is positive. And if you think about it, if we have an odd number of negatives, we're going to end up with a negative result. An even number of negatives would result in a positive. Now let's move on to test x equals 3. 3 minus 2 is positive, 3 minus 4 negative, 3 plus 4 positive. And so we're going to have negative y values between x equals 2 and 4. Plugging in 7, we get 7 minus 2 positive, 7 minus 4 positive, 7 plus 4 positive. So positive y values to the right of x equals 7. Positive y values to the right of x equals 4. Now, what are we looking for? We're looking for where our function is greater than 0, meaning positive. So if we circle those two plus signs on the sign chart here, we can see the solution would be negative 4 to 2, not including negative 4 or 2, union 4 to infinity, again not including 4 there. And if you look at the solution we got when we solved this inequality graphically, again we agree with what we got previously solving this very same problem. Okay, let's go on to solve the rational inequality x plus 1 over x minus 2 is less than or equal to 3. And I want to get a 0 on the right hand side before anything else. So let's subtract 3 from each side to get x plus 1 over x minus 2. Minus 3 is less than or equal to 0. We want now one fraction on the left side. It would have a denominator of x minus 2. So I'm going to have x plus 1 minus 3, and I need to multiply 3 by x minus 2 to put it over our common denominator. We simplify the numerator to get x plus 1 minus 3x plus 6. And then further simplifying, I get negative 2x plus 7 over x minus 2 is less than or equal to 0. Okay, so at this point, I'm going to grab this rational expression to the left of the inequality sign, give it the name f of x. So I have f of x equals negative 2x plus 7 over x minus 2, setting the factor in the numerator equal to 0 and the factor in the denominator equal to 0. We get negative 2x equals negative 7, or x equals 7 halves. We get x equals 2, and from there we'll create a number line. Put each of these x values on our number line, so we have 2 7 halves. Noting that 2 comes from the denominator, the function would be undefined at that value. Let me fix that. And at x equals 7 halves, coming from the numerator, we would have a 0 at that point. Okay, so again, let's test a x value in each region. So let's test to the left of x equals 2, I'll grab 0. Between 2 and 7 halves, 3. To the right of 7 halves, let's try 5. Okay, so let's see what we've got, positive or negative. So plugging in 0 into my function here, f of x, negative 2 times 0 plus 7 would be positive, over 0 minus 2 is negative. So I end up with negative y values to the left of x equals 2. Between 2 and 7 halves, we plug in 3. Negative 2 times 3 plus 7 is positive. 3 minus 2 is positive, so I have positive y values in that region. To the right of 7 halves, if we plug in 5, we get negative 2 times 5 is negative 10, plus 7 would be negative, over 5 minus 2 is positive, so to the right of x equals 7 halves, y values will be negative. And now we look at what we're trying to find here to finish solving the inequality. We're looking for where our function is less than or, whoa, where am I at? We're looking for where our function is less than or equal to 0. Okay, so that would be where we have negatives or where we have zeros. So let's see where we got. So we have negatives here, and then we have 0 at 7 halves. The solution would then be negative infinity to 2, not including 2, union 7 halves to infinity, and we do include 7 halves here. Okay, so there we have a solution. Let's go on and solve one more rational inequality. I should note, going back just a sec here, this is the same inequality we solved graphically. So you might check this solution with the solution that we got when we solved this graphically. Now, solving 3 over x minus 2 is greater than 2 over x minus 3. Again, I want to get a 0 on the right side here, so I'll subtract 2 over x minus 3 from both sides. And that will give me 3 over x minus 2 minus 2 over x minus 3 is greater than 0. Then we want one fraction on the left side. So let's get a common denominator, x minus 2 times x minus 3. To put 3 over that common denominator, I will need to multiply by x minus 3. To put 2 over that common denominator, I will need to multiply 2 by x minus 2. And then we'll simplify. We have 3x minus 9 minus 2x plus 4 over x minus 2 times x minus 3, and we get x minus 5 over x minus 2 times x minus 3 greater than 0. And now we can grab this rational expression on the left side, give it the name f of x, so we have our function f of x equals x minus 5 over x minus 2 times x minus 3. And I set each factor in f of x in the numerator and the denominator equal to 0 to get x equals 5, x equals 2, x equals 3. And these numbers will be the endpoints of solution regions when we solve this inequality. Let's draw a number line. Put these three numbers on the number line, 2, 3, 5. And then I'm going to identify, well, x equals 5 comes from the numerator, so we would have a 0 at x equals 5. X equals 2 and x equals 3 come from the denominator of f of x, so would be undefined function values for those x values. Okay, and now let's test a point in each region here. So let's test. To the left of x equals 2, let's try 0. Between 2 and 3, we'd need what? 5 halves. And between 3 and 4, or 3 and 5, let's choose 4. To the right of 5, oh, maybe 8. Okay, so now let's test 0. 0 minus 5 is negative, over 0 minus 2 is negative, times 0 minus 3 is negative, resulting in negative values for y to the left of x equals 2. Between 2 and 3, plugging in 5 halves, we would have 5 halves minus 5 is negative, over 5 halves minus 2 is positive, 5 halves minus 3 would be negative, so we get positive y values here. Plugging in 4, 4 minus 5 negative, 4 minus 2 positive, 4 minus 3 positive. We get negative y values between x equals 3 and 5, and then we'll plug in 8. 8 minus 5 positive, 8 minus 2 positive, 8 minus 3 positive to give us positive y values to the right of x equals 5. So what are we looking for here? Well, let's go back and look at our function f of x. We want f of x to be strictly greater than 0, which we would only look for the pluses here on the sign chart, and we would see our solution is 2 to 3 union 5 to infinity, not including 2, 3, or 5 in the solution. Try on your own number 2. Solve the rational inequality algebraically. X plus 3 over x minus 4 is less than or equal to 2.